Okay. The first part is the quiz. I'm glad you grabbed that.
What's the quiz on?
Huh?
What's the quiz on?
You're doing it right now.
Everything that's in this bag?
I can't tell you any more than you know. You can only use what's in the bag for the quiz. This is
You
the,
could have told me that. I did ask you that.
I did kind of say the bag. I referred to the bag.
You didn't say the bag.
The bag is everything and nothing is missing on the bag. And it's optional to use those or
I
those.
don't want those. I want these. I've done this. The last time I did these.
I know. This is just the intro to the class. It's like a review.
Why isn't there 2 wires?
Well, there's only one wire. You only need one wire.
There should be 2 wires.
You only need one wire. That's part of the quiz, is only having one wire. It's a dexterity quiz and it's a knowledge quiz.
Can I use your hands?
No, that's part of the dexterity part. No, you can't use anything except what's in the bag. Yeah, I guess that's legal.
You said I could use my. This wasn't in the bag.
What?
My knees. Why didn't I?
The key word is circuit.
Yeah, I know what a circuit is.
What you just did there was not a circuit.
That's a circuit, isn't it?
Okay, you're connecting 3 things together, and that you never do that in a circuit. A circuit is a circle. That's the whole point of the word circuit. It comes from the word circle.
I know.
Make a circle.
Okay, I made a circle.
How many conductors are on that bulb?
1.
How would electricity work if there's only one? The whole point of a circuit, if there was just one conductor, you have an end. It's like a T with an end. It's not a T, it's a circle. Electricity goes in a circle. The electricity goes through the wire. Electricity goes through the battery. Electricity goes through the bulb. You're connecting 3 things together, and you don't ever do that with a circuit. How many conductors are on that bulb?
2.
Where are they? Point to them.
Here
Right?
and here.
Anywhere else. The whole rest of it. Even that bottom portion, this metal, and you know that that's one conductor because it's metal all the way from here to here, and there's an insulator between that point and this point. So you have to make electricity go through that bulb. Don't try to connect 3 things together. That'll never work. You're going 1, 2, 3. That'll never work.
You could help me.
No, I can't. I've been helping as much as I could with the circuit. You want me to draw you a picture?
No, I don't need a picture. I don't need a picture.
That's a battery. That's a light bulb. Make a circle. It goes through all the points.
Okay. Do I need both batteries?
It'll work better with both batteries, but you don't need both batteries. Don't ever connect wires up to both sides of the same battery. It'll kill the battery. You started your circuit. That's good. Okay, that's good too. Put it on the side of there. On the side. And now how do you finish the circuit? How many conductors does the battery have?
2.
Where are they?
Top and bottom.
Okay. You just passed the quiz.
Top.
try it like this. It'll be a little brighter. See how much brighter it is?
Mm-hmm.
Why is it brighter?
Because you have more voltage.
You have more voltage. You have 1.5 volts plus 1.5 volts
That's
equals
3.
3 volts. So it's called a circuit because the electricity makes a circle.
Mm-hmm.
It goes through the batteries. It goes in and out of the light bulb, going through the light bulb, through the wire, in and out of the wire, and back to the batteries. It's a circle. You see how it's a circle? And you notice there are no places where there are 3 things connected together. Here, it's a bulb and a wire. Here, it's a bulb and a battery. Here, it's a battery and a battery. Here, it's a battery and a wire. And all the way back to make a complete circle or a complete circuit. The word circuit comes from the word circle. Okay? So let's just put this to the side because we'll need parts of it.
And now what?
So, the next thing, if we were going to use these two, that's why I have 2 sets here. Let's do the same thing again real quick. Let's use both of our hands so we can do it quicker. I was just going to hold one end so you can hold the other end. You just pinch it with your finger. You don't have to.
I'm gonna grab
It's not working. Why not? Let's try it this way. It's not working. Let's try it this way. It works. Very dimly. This one worked, this one didn't. Why?
One's dead.
This battery's dead. Which takes us to part 1B. This is a battery tester. Very handy thing to have around the house.
I don't know how to do it.
Match the plus to the plus and the minus to the minus. Look at the plus and minus first. Where's the plus? There's the picture of your battery. Plus. Very good. No response. Very good. So I'm going to keep those to the side. Test these two. Very good. So, a battery tester is a handy thing to have. Another thing that's handy to have, anytime you're doing more than just simple things like we just did,
Yeah.
is a battery box. What this does is it holds the batteries and then gives you a way to connect your circuit so you don't have to hold everything with your hands. I'm just untangling it is all I'm doing. Well, don't get upset with me every little thing I do. All I was doing is untangling the wires. You always want to check your polarity. Plus to plus, minus to minus. And now you don't want these two to touch because that'll destroy those batteries very, very quickly. In 5 minutes they'd be dead because it's just making a circuit heating up the wires. Very good. That's what I was going to do next. And all this is a socket that touches the butt and the side of the bulb and gives you 2 easy connections. This connection is touching the side. This connection is going up through the middle and touching the bottom. So it's still making a circuit where the electricity goes into the light bulb and out of the light bulb. That's what a circuit is. In on one conductor, out on the other conductor. So that's that part. More on circuits. A circuit is anything as complicated as you want it to be, as long as it's a complete circle. So what's going to happen when I touch these two?
It'll light.
It's still a circuit. I just added another piece of wire, right? You got a little bit of intermittent. I'm not sure why it's doing that. Maybe because the light bulb is about to burn out, maybe because the batteries are weak. I'm not sure why it was doing that. So, The next thing is, a fuse is like a piece of wire.
Uh-huh.
You have an in and an out,
Mm-hmm.
an in and an out. You can even think of it as a plus and a minus.
Mm-hmm.
If I connect this up and touch that to that, and touch that to that, and put it through that wire, it makes a circuit. This wire is part of the circuit now, right?
Mm-hmm.
What if I replace that wire with a fuse? Let's do it with the wire first. That's a circuit,
Mm-hmm.
right? What if I put this fuse in there? If you notice that fuse has a little pink dot,
Mm-hmm.
put that on there. What's wrong?
It's not lighting
Why?
because of the pink dot. Because the fuse is dead.
What's not happening in that fuse? The electricity is
Not going through it.
the electricity is not going through it, so it's breaking the circuit.
Mm-hmm.
Here's another pink dot. Don't let this one bounce like you did that one. So, this one turned the light on, this one didn't. What's the difference between those two? Oops, I shouldn't do that.
This this fuse is broken. This one isn't.
Right, this one is an open circuit, like a broken wire. This one is a closed circuit, like a complete wire. A fuse is a safety device. There's many different kinds of fuses in the world. The most common one is a fuse that burns out when it has too much power.
Mm-hmm.
That's the kind of fuses we have in our house. That's the kind of fuses you have a lot of them in your car.
Mm-hmm.
Usually it just looks like a little glass tube with a filament in it. It's very similar to a light bulb. When there's too much power going through it, it burns up and creates an open circuit which protects the other things in that system. Like in our house, our fuses protect our house from burning down. The fuse breaks without overheating a wire. There's wires behind this wall. If those wires overheated, it's going to burn that wall up. But what happens before those wires overheat? The fuse over there trips. It's annoying, but it's easy to fix, and it doesn't cause a fire.
Yeah.
So that's what a fuse does. So we compared a good fuse to a dead fuse. This is the part that made the washer or the dryer stop working.
Mm-hmm.
It got too hot. This is not a current fuse where it stops working when there's too much current and there's too much power. This is what's called a heat fuse. It burns itself out when there's too much heat. The dryer got too hot because there was too much lint built into it, and it was stuffed up and the hot air had nowhere to go. It's supposed to go outside. And it got too hot and it was in danger of starting a fire. So this fuse gave its life to protect the chances of a fire. So this fuse is now dead, and I had to buy a new one. And I might show you where that goes. So a fuse protects either a circuit or something else.
Okay.
It's a protection device. Compare the good one to the old one. So we can test this fuse, right? Test this fuse. Tell me if it's good or bad.
It's good.
So test this one.
That one's bad.
Test it. Okay, test this one.
That one's good.
So, we know it's good because there's power going through it. It's completing the circuit. And in a dryer, completing a circuit makes the thing run. With a light bulb, completing the circuit gives you light. So, my little bit of testing of these devices. It took me a long time to even find where this was in there. I had to go on the internet and do some research. I knew there was something like a fuse that was bad, but I didn't know where. I started ripping things apart, and you saw all the pieces everywhere through the house until I found that, and I had some help from the internet. And then I tested that fuse to see if it was bad or good. When I found it was bad, I went and ordered a new one. That effort saved me $700. Because the other alternative is to have somebody come in and fix it, which is expensive, or throw it away and buy a new one, which is what most people do, and that's expensive. So, the next topic is a switch. Do you know what a switch does? What's going to happen when I connect this to here and that to there? Let's do it this way. I'm going to make sure these aren't touching by accident. If they're touching, it defeats the purpose.
That's off, that's on.
So, how is that any different than this?
Listen.
It's exactly the same. The only difference is this is 3 volts and this is how much?
100.
That's a number you should memorize. It's close to 100,
150.
110, 112. Just if you say 100, that's good enough. 110, 112 volts and a lot more amps. We'll get into volts and amps at some other topic, not today. But basically, a switch is what? Completing a circuit. When you close the circuit, it's okay, I know. When you complete the circuit, you close the circuit and things can do a circle and stuff. You either run a motor, you turn on a light, you do something with that electricity. Your battery or your power is doing work. In the case of the power, it comes from someplace downtown through wires to our junction box that we pay for. That's doing the work. Right now, the batteries here are doing the work. What's happening inside this switch?
I don't know.
Basically, all that's happening is there are 2 pieces of wire, and that switch is a mechanical device to bring them together, so that we can operate plastic and touch plastic and not metal. All that's happening inside there is there are 2 pieces of metal connected to the whole circuit that are coming together and touching. That's all a switch is. It's a fancy box around 2 pieces of metal coming together. Okay? When the repairman comes out to work on your device, well, those guys just want to stick together and ruin the battery, to fix your washer, to fix your whatever, is he going to have little pieces like this and wires and all this kind of junk? Is it easier to test a battery quick? If you wanted to test that battery really fast, what would you do? Boom, you're done, right? Would you sit here and if all you want to do is test that quickly and be done and not have to waste a lot of time, would you do it that way, or would you build a circuit and play with it?
Do it this way.
Right. That's what this guy is. And this is the last topic. This is a multimeter. Hopefully, yeah, right there. Multimeter. This does a lot of things. And we're only going to talk about 2 things that it does right now. This was an expensive gadget. I own about 6 of these, but this is the best one I own. So, plug this into there. Right there. And you'd have to know where to plug this one into. Right now, I want to plug it into the one that says ohms on it. Right there, that one. You see that little weird omega with the feet? That's ohms. Push them all the way down. And now we want to put this on ohms, right there. See that circle with the feet? That's omega, which is the signal for ohms. What it's doing is it's checking resistance between here and here. How much resistance is between these two right now?
None.
Infinity.
Okay.
Resistance is something that resists. Like if I wanted to keep you from going outside, I'm going to resist you from going out there. Right now you have, okay, so anyways, when I touch these together, it's going to go to 0 ohms. That means there is no resistance. If I test something, maybe this light bulb will have a small amount of resistance. It's still 0. That's kind of unexpected. But anyways, a tester like this lets you test something quickly without having to build the circuit. So, take these and play with that. Just play with it. Is it acting like... Yeah, you can do that. This is just a shell around it, so it's a ground. So that's not surprising. Those aren't conductors. It's just part of the case. So is that acting closer to this or this?
Yes.
Which is it acting more like?
Yes.
So it's acting like an open circuit or a closed circuit? Open circuit. Test this one. That means there's a wire going between there and there, which means this fuse is
Closed circuit.
a closed circuit, which, is it a good fuse or a bad fuse?
Good fuse.
It's a good fuse because it's allowing electricity to go through it. That one. That one. Which is the bad one of the three? This one's bad. You just tested 3 fuses in like 10 seconds. That's why a multimeter is a handy tool for a homeowner or a electrician or a guy who builds and fixes these things. You don't have to build a circuit. You can just carry this one thing around and it tests hundreds of different things. The next thing it tests, and the very first thing I did when I was trying to figure out the dryer, I thought, well, maybe the outlet was bad. So there's another setting on here. It's called volts AC, volts AC auto range. How many volts are there right now?
0.
0. There's no power. So now we're going to do something that you normally don't want to do. We're going to put this,
Dad, there's one up
stick some wires into the wall.
Dad, there's one up here.
Huh?
There's one up here.
Oh, there's one here too. I'll do it there and give it there. You don't ever want to stick wires into the wall.
Okay.
But right now we're going to stick wires in the wall. Stick one into the other one. Stick it all the way in till it touches. What do you see?
12. About 12.
It's actually reading 120 volts because that's what it reads when there's no load. The actual official standard is 112 volts.
Okay.
So the very first thing I did when I was testing the dryer is I pulled this out and I tested that outlet. That outlet is a little different than normal outlets. It's 2 outlets tied into one. The normal outlet is 120 volts. Let's just go with 120. Normal outlet is 120. This is actually 2 circuits tied together, back to back. So it's 2 times 120. This sucker runs on 240 volts.
Yeah.
That's why it's a different size and shape plug. And it's something to be even extra more careful of in a house. There's only 2 things that I know of in this house that takes that much power. Well, the refrigerator standard 120. The oven has a special big plug that takes 240. So the dryer takes 240, the oven takes 240. Usually it's something with a big heat coil. The motor doesn't take 240, but the heat coil does. This washer is standard 110. It's all it has. The thing that takes the most power here is the motor that turns the drum. Everything else is open and let water in and push water out or a little pump. Who cares? There's nothing in there that takes 240 grams. So that's the end of the class. Do you have any questions, or is there anything you want to play with more?
Nope.
Because usually at the end of your classes, you get to play a little bit, right?
No, because usually class is over.
Well, this wasn't terrible, was it?
No.
All right, we're done. Thank you for listening. I'm going to stop the video. Oh, and guess what?
It wasn't recording.
No, it was.
What?